ladies and gentlemen, I can't believe we're actually starting our very last chapter here. Chapter 11 for us. It's actually chapter 12 in the book if you wanted to follow along or need to look anything up. But it's on statistics. A lot of this we did last year in 7th grade, so I'm hoping that you're going to find it pretty easy. We're also going to do some work with our calculators as well, so make sure you're bringing your calculators. Today we're just going to be looking at graphical displays of data, being able to read different types of graphs. So quantitative data on a single variable is often collected in order to understand how a characteristic of a group differs among the group members or between groups. Quantitative, you have to remember, it's talking about quantity, which means we're dealing with number answers, okay? So how old is a typical fast food worker? So the answer to that is going to be a number, not what fast food restaurant do you work at. That's qualitative. You're talking about a quality of something. Okay, so here's an example. We have Charlie's Food Factory currently employs 28 workers whose ages are shown below on the dot plot. Answer the following question. So how many of the workers are 18 years old? So if you find 18, 15, 16, 17, 18, and then you're going to count the number of dots. Each dot represents one person unless they tell you otherwise. What is the range of the ages? So you have to find the range is always highest minus lowest. So that's 42 minus 16. So I believe that's 26. Would you consider this distribution symmetric? Well, symmetry means that it looks the same on both sides. So no, I would not. There's definitely a higher grouping down here in the lower age range than there is in the upper age range. The mean or average age for a worker is 22 years old. Why is this average not representative of a typical worker? Well, you have some outliers up here, right? So you have a few outliers that make the average higher. Remember, average and mean are the same thing. So these people up here, they're so far away from where they're clustered, they're going to make that average appear to be higher. It looks more like they're somewhere anywhere between 18 and 19 years old as opposed to 22. All right, now we actually want to make one. A farm is studying the weight of baby chicks. After 1 week of growth, they find the weight in ounces of 20 chicks. The weights are shown below. Construct a dot plot. So every time you see one, you have to put a dot on here. So we have a 2, a 1, 3, 4. I'm going to pause it. You guys finish this and come back and check it. Okay, hopefully you have something that looks like this. There should be 2 at 1, 3 at 2, 1, 2, 3, 4, 5 at 3, 4 at 4, 5 at 3, 2 at 6, 1 at 8. Okay, so there it is. Again, 1 dot per person. Try to line them up nice and neat, or per weight, I should say in this case. All right, next one. This is something called a histogram, which we dealt on with before. Histograms are where you don't have any breaks in between and you're grouping your data together. So we're talking about the ranges of people at Charlie's Food Factory. How many workers have ages between 19 and 21 years old? So that's right here, this grouping. So that's going to be 11 workers. What is the disadvantage of a histogram compared to a dot plot? The histogram it groups, so you can't look at the ages as separate. Data is in groups. So you can't determine some info. Okay, does a histogram have any advantages over the dot plot? It does if you are looking for, it tends to show more of where things are located, but we'll talk more about that one in class. Okay, now they want us to actually do a histogram here, so complete I'm going to fill in the tallies. Again, I'm going to pause it, and then I want you guys to come back and try it as well. Okay, hopefully you were able to fill those in and I didn't make any mistakes, so they matched. So when you're actually constructing the histogram, down below is where you're going to put your ranges. So in this case, it's points scored. Your y-axis is always the frequency. So we have to only get up to 8 on the frequency, which means I'm guessing we can probably go by 2s. Of course not. Well, that just stinks. Okay. 1, 2, 3, 4, 5, 6, 7, 8. I was hoping to spread it out a little bit, use more of that graph. We have 1, 2, 3, 4, 5, 6 categories. So hoping we can do, you're not skipping spaces in between. So we had 3 people who were between 40 and 49. We had 8 people between 50 and 59. You could color yours in, I'm just trying to save some time here. 6 people, notice the bars are touching. In the 70s we had 2. We had no one there, so that should be at a 0, and then we had 1 person. Okay, so when you're doing a frequency table, your ranges, your intervals always have to be the same size, so and they can't overlap or skip anybody. All right. Oh, look at practice. So we're done. Okay. Any questions? Hopefully you found this pretty easy. Oh, I did forget a title. I'm sorry. So this should be points scored. Because any good graph, as we know from science and math class, has to have a title. You might want to even be more specific. The 2006-2007 Arlington High School varsity boys basketball team, and so on. So, okay. Again, any questions? Bring them to class. Have a good night.